Thanks, Joachim, for the introduction. I hope you sit safe for the last flight we do today. The last presentation, I know everybody is a bit exhausted due to the long days, the long 2 days. Me in AUMOVIO, I take care for making operating systems on microcontrollers and to bring it into the projects. Therefore, it's a nightmare for us if we have thousands of variants on thousands of different stages. We would like to do reuse. And in order to enable this, we have thought what we do with our AUTOSAR layered architecture. I think this picture is known to everybody. We have a stage 0 where we have the pure AUTOSAR modules. Then we get an MCAL to it. We make a hardware platform out of it. Then comes the next stage. We make an ECU platform, probably for a product, and then we want to go into an application project. So in the end, we have 4 stages, which we have to manage from a software point of view, and we have to manage it consistently, and we would like to push it from one stage easily to the next stage. Otherwise, it's a lot of work, and as we learned, time is key. We have to be fast. So we thought, how we do automate this? We would like to have a software factory where you can push the things through. We have the package development according to the standard. We bring it on the hardware. We make a product platform, and then we go into a customer project. And the idea is always this stack is used in 100 projects. Let's call it, we have 10 different hardware supported. We have 3 ECU platforms where we make then 20 customer projects of. And this all has to be orchestrated together. So the first level is for the asset creation. Then we change the configuration when we go on a hardware. We use Conan to hand over the packages for the next level. And then we have to propagate in case that we change things from one level to the next one. I think every one of you has to do so if he works at a tier 1 and has to manage the situation. So in the first stage, when you do software assets, we have stacks which are available, standardized interfaces. We have a layered architecture, diagnostic services which are mature, and we can maintain it over a certain time. But when we look at the standards, as we looked, what should I give to Christian, who is in the PL team? Where should we work on in the AUTOSAR standard? We saw, well, if we combine in these stacks modules of multiple vendors and use the generators according to it, it's a nightmare. So, not so good. We have thousands of configuration options. I think we heard it several times with several ideas to do it with AI and whatever. From my point of view, too much to be tested. So I would be happy if they get reduced. If it comes to a dynamic behavior, we see not everything is there specified. And in regards to performance and footprint, nobody makes a statement and looks at it. So the recommendation would be to the standardization. Let's look on classic platform and tackle the topic of the number of configurations. Martin Lund has there done a good survey, and I think we'll come there a step further, but this we have to take care in the standard. And then if we use assets of different vendors, we need an interoperability test. Without this, you cannot mix the stuff. So, oh, I went in the wrong direction. Now here. Then we go to stage 2. We apply it on a hardware, on a microcontroller. So the AUTOSAR really helps us. We have in the meantime a very standardized MCAL, which you can use. The problems we see now with a more mightyful or powerful microcontrollers, we have thought of a one-core model mainly, which we specified. We did some work in terms of multi-core, but it's not, let's say, completely worked out that we have a unique way of how to do it. So the modern hardware has to be tackled with multi-core. Everybody has a different solution, how he makes the communication there in between the cores. And what we also see, the HSM implementations, we would like to exchange them. And there also we see here and there problems due to the missing specification in the standard. The resource usage, we should look on it, and also all this time engineering, I think it needs a bit more thinking of. So what we would propose is we have to extend it to microcontroller classes, how we specify it, and also profiles for different setups for the small, medium, high, or however we want to do this. The proposal from Martin, he has shown, and he is advertising, Martin Lund, I think will go in this direction exactly. Then let's go on the next level, and you see we are adding step by step. We would like now to do a product platform of ECU, which is doing something. We add there another modules. So we take it over from the previous stage, which works well. We do a new configuration, fine. Also here we have the topic with the profiles for different ECU classes, that this makes us the problems, as you always have the full stuff, where you have to then take care for all the cases if you go on the next level. So here also we have to restrict the configuration options via the profiles. And finally, we arrive in the application project in the fourth stage. We can configure it completely. It's for all stacks. What we see, then there come the famous OEM extensions. And some of the OEMs give us special modules which you have to integrate. We have inconsistency in the ECU configuration where we can find the stuff out with the tooling. And also, the colleagues told it today, it gets more and more complex. I just remind you on the talk from the Vector colleague who said they have a zone 1 million configurations, which you have to handle on this level. So what we would like to have, which makes our life then easy in the end, no separate modules, module modification on this level for OEM specifics. We have to have it as a configuration in the standard. So I summed up all the unsolved issues we have. We have to extend our workflow examples. We have a kind of monolithic architecture. We have to make it more modular for agile development. We have to reduce the configuration and adapt it to more complex hardware, the classic standard. And very important, interoperability for tools and stacks in between. Otherwise, if you mix stuff, it gets complicated. So therefore, there are some takeaways for the standard, and for you, if you work in such a setup, the only way to manage it properly is with a reduced set of configuration. We start with interoperability tests. We have to extend the classic platform on different microcontroller classes and restrict the configuration options and OEM specifics to put it in configurations only. So this is what we see as lessons learned, setting up such a software factory, using it with classic AUTOSAR for all our microcontrollers and trying to serve all projects out of it. And I think this is a kind of my wish list, or I would give to the standard to be realized. So it's a kind of my wish list to be implemented into the standard. So for me, is the question, do you see the same problems, limitations? If yes, I would welcome you to help there in the standard to get these topics solved. And for me, the classic platform will remain and will continue. And it's, for me, a cornerstone for modern EE architectures. Exactly for this, we have to work on it to make it better. And if we don't work there together, we won't fill there the open space. And please help us there. Your voice matters. Thank you.
Thank you, Thomas. Any questions to you?
If there is no question out of the round, then I would ask a question to the round. Am I allowed to do this?
Yeah, go ahead.
Joachim? So, how is the feedback of the people who are involved? Do they see the same problem like I'm seeing? Who has these problems? Hands up. So Todd, IP, Martin, Christopher. What would you expect? Is it okay to give this to the PL team, this list, what to be done? In the end, if you don't speak up, they think there is no problem. I think there is a problem, and I tell it to the PM team all the time, but if I'm alone, I'm alone. As you learned yesterday, alone you can go fast, together you can go further. And I would like to go further with it. Just to copy the sentence from the iSoft guy.
So I think I have the same issue in my project. Sometimes we have a better configuration, but we choose another way or manual code to implement this to solve a problem, but we have a better solution in configuration. So our engineers actually don't know there is a better solution because there are so many configurations that we need to currently the AUTOSAR, classical AUTOSAR offers us. So I also hear about there's a project to reduce. I don't know if there's an ongoing project in AUTOSAR internal to reduce or simplify the standard.
Maybe Martin, you stand up with the ECU classes, and maybe you can say one word to it.
He wasn't done yet.
Ah, sorry.
Yeah, of course. So I'm here about there's a project that is ongoing to reduce the specification, or so that we make life easier. So for this question, I think it is tough for me because I'm also have some bad feelings, but I'm also I don't know what to do. Maybe we can use AI to simplify this, or so I'm still considering this, how to solve this problem.
Maybe my suggestion is because there's more votes from OEM, we say this time it's supplier features and OEM features, and then if all the people in the core partners from the suppliers, then it's on your list. Yeah.
Perfect. Thanks.
There's W has a comment.
Maybe one comment for complexity and configuration effort. We have heard a lot of presentations how AI could help you to configure your system. And I think we from the AUTOSAR organization are aware that especially if you start a new AUTOSAR project, that you're overwhelmed with all the freedom you have when it comes to configuration. So what we will try to do, we already started the so-called CP evolution project, which tries to tackle exactly these difficulties. So what we want to achieve is to first step to provide you default values, meaningful, that if you don't touch the configuration, that you already from the beginning have an meaningful behavior of the ECU, so that everything fits together. The second thing is where also Martin Lund is working also together in the AUTOSAR organization to try to have this ECU classes. So it should also help you, depending on the ECU size, to make a proposal which features you're using. Like if you have an CAN ECU and you want to do security, that you then automatically are proposed to use SecOC, for example. Or if you're using an Ethernet ECU, then you're proposed and you want to do security, that you use, for example, then MACsec or IPsec, things like that. Also, for safety, we have different ECU end-to-end profiles, depending on the payload on the bus, that also, if you use, for example, CAN or Ethernet, that the different correct ECU end-to-end profiles are proposed. Yeah? So we are working on this. Yeah? And the other thing is, of course, reducing features maybe, which are not needed anymore because technology has evolved to also reduce here complexity. So we are on it, we are aware about it, and we try to make the entry point for AUTOSAR users much easier.
Great answers. So, but I still because in real project, I think we still have some challenges, like we still need to find several solutions. We don't know which one is the best solutions. So if AUTOSAR could provide some best practice, like just the answers saying, but so that would be very helpful for AUTOSAR users, I think. Yeah. So that's my suggestion. Provide some best practice like on AUTOSAR stack.
I just made a quick count, and right now it's 5-5. So it's 5 suppliers, 5 OEMs, and some of the OEMs right now are a little bit passive. So actually, you have if you vote for it, you're in.
You know, I worked always for it.
Yeah. No, that's why I'm saying I think there's a good chance. There's another person. Okay.
Hello. Thanks for the presentation. This is Marius Rotaro from NXP. Always, when we start defining a new silicon, we try to understand how to make it AUTOSAR compliant, which is very good. It's the only standard on the market. When we develop the software for that silicon, we want to check the compatibility with AUTOSAR. The main problem is that there is no open platform, any blueprint where we need to try the compatibility, where we want to contribute to the AUTOSAR, put our drivers, enable our silicon in order to show not only the performance of the silicon, but also demonstrate how efficient the AUTOSAR functionality works. So to me, instead of doing and optimize the configuration, it's more important to have a blueprint, to allow everyone contributing into the AUTOSAR, demonstrating the AUTOSAR functionalities, highlighting the problems. That's from the semiconductor vendor, the perception.
So
and the need.
So what might it help you to have something similar, like you know it from the mobile market? If you do an application, you do there a check somewhere, and then it tells good application or bad application. You still have
Exactly,
something
but
to do.
Just to tell you, I port Android Auto on our hardware, and it works. I have validation tests. I can optimize the Android Auto for our silicon. I want to do the same for classic platform as well. And then I want to maybe narrow down the configuration depending on the domain. I say this is the configuration which is suitable for gateway devices. This is configuration which is suitable for powertrain. It is because we know somehow better our devices. And this is what we need. Currently, we end up in working with all the AUTOSAR providers in order to enable our hardware. We don't want to do this. We want to have a blueprint where, in fact, we want to deploy and show how the AUTOSAR is working on our hardware. And then let all the partners we have to productize it, to commercialize our solution plus their solution.
So you're asking for a
I
complete
ask-
stack to do it.
Exactly.
And then
Then
who is
once
doing your MCAL?
And then once you have the complete stack, all of us will understand the difficulties of having many parameters, what parameters need to be optimized depending on the domain AUTOSAR is targeting, etc. Could be a solution instead of just discussing and removing some functionalities from AUTOSAR.
Yeah, there's both parts of it. One is reducing complexity of it. That's what we're doing. I mean, and if you look at also at the roadmap, I didn't explicitly point it out, but the majority of evolution right now is on the CP platform. And
That's
it
correct.
is in complexity reduction and ease of use.
That's
And
correct.
I think it's a good discussion, which we need to have in order to get there. And I see the pain, but I think there's anyway on the roadmap. But I think you're invited to contribute with your team, and we're actually the biggest problem is not actually the money we are getting for. The biggest problem is the number of people really contributing. Yeah? And so we have too many observers and not enough contributors. And so you're invited to join improving it. And so I think it's a great opportunity to do it.
It is, and we are there. It's not a problem. The problem I told you, there is no environment where to contribute and debate. We just talk to change some configuration and parameters. Let's have a blueprint where we show what need to be optimized and why need to be optimized. That was the point from
No, I
our
understand, and
perspective.
I think we want to do it as well, and therefore I'm inviting you to help us with some
Absolutely.
people from your team and other groups. We can solve it together.
Why I'm saying this? It is because there is saying that other standard might come, de facto standard in a few years, nobody contribute. Yes, this is true, but the other standards like Zephyr, for example, they provide the entire framework, which is open source. And we go there, contribute there from the driver's perspective, but also from the middleware perspective. We like to do the same with AUTOSAR Classic platform as well.
So I translated in other words, what you propose is to make CAPI for classic platform.
I understood the same, exactly. Yeah, this was my thinking as well.
Yes. So fully understood, and
Yeah.
I'm a bit comforted that it's not only me who has the problem.
Yeah.
I have also the microcontroller suppliers have a similar pain.
Okay, I think
Perfect. The ground gets bigger.
Yeah, exactly.
Who
And I
wants to
think it's
change?
enough to do it. So it's enough people. But I mean, beyond voting is really that we have also then the people doing it.
Yes.
Yeah. But thank you.
Thanks.
Maybe a last question from my side on the amount. I mean, if you look at your production projects right now, how much percentage is AP and how much is CP?
AP is 5%. Classic platform is
95.
at least 95 or more.
Okay, okay. And then how many is your projects in parallel we're typically talking, which you have to support?
More than 100.
More than 100. Okay. So it's pretty much 95 to
Yes.
5.
And this also makes the
Okay.
importance of the classic platform.
I understand.
Still.
No, it was clear to me.
So-
I mean, I just wanted to get the number so that everybody in the room has a reasonable understanding on the
But
size.
anyhow, we talked about this when we talked about classic and adaptive. The number of ECUs with adaptive is a factor 10 smaller. in the vehicles then.
Oh, yeah, this was clear. I mean, you see it, like even if you just translate the architecture pictures, which we
Yes.
saw from some of the slides. I mean, yeah, there's maybe 2 or 3 in a car, and the others is like if we listened to a BMW earlier today, it was 25, 30, and in the
Then you
bigger
count how
company-
much are
Yeah, exactly.
adaptive and the rest is classic.
No, it's clear. And then there's some Lin nodes, which is different. Okay, one more question. If not, then we have a little bit time until the other room is done, and then we group here for the last on the Q&A. So, okay, thank you.
Thank you very much.